Hello guys and welcome back to another video tutorial series on system design. So let's start with today's video of system designing, and today's topic is load balancing. So in my previous video tutorial series on system design, I was discussing some of the main characteristics of a distributed system such as scalability, reliability, availability, efficiency and the maintainability. And before appearing to any technical interview on system designing, you should know these 5 core concepts because these 5 characteristics are the pillar of system design. So if you do not know these 5 concepts, I would highly recommend you to go through my previous video first and then come back to this video so that it will be easy for you to understand the flow. So let's start with today's video tutorial series on load balancing, which is one of the key concepts of system designing which you have to know before designing a system. So without wasting much time, let's understand in detail the concept of load balancing. And let's understand that what is a load balancing, why we need a load balancer, and where we should incorporate a load balancer in our system design. So before moving forward to this video, I would highly recommend you that if you are new to this channel, please do like and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with understanding the concept of load balancing. So before sharing the theoretical knowledge on load balancing, let's first understand the concept in detail. So let's take an example that you are the owner or the system designer of an online retail business store, and you have successfully hosted your website in the internet to attract more and more customers into your business. But to keep it simple and easy, for the first iteration of your online retail store, you have just uploaded a simple website to publish your products, and you have not considered any of the system design principles for supporting any large-scale application that we have discussed in our previous video. Now let's assume within a few months of your business, you are getting a good number of customers in your online business. And since the amount of customer coming into your business is quite low during your initial days, so there is no lag or downtime for your application, and your website is performing as expected, and hence all your customers are happy with your service. But as the days are passing by, the numbers of customers are increasing gradually, and sooner or later, within few months, your small scale website cannot handle the amount of traffic it is getting from the online customers, and eventually your website will crash, which will not only make your customers unhappy, but also it will cost you a huge loss of money for your business, because very soon you will be losing all your customers because the website you have created for hosting your online business is not suitable for handling this huge number of traffic for your business. So now you need to take some immediate action to support the huge number of online customers that you have, and to make the customers happy again with your service, you need to scale up your application to a huge extent. And so you need to scale up your application using the two methods that we have discussed in our previous video, and that is vertical scaling and horizontal scaling. So to scale up your application using vertical scaling, you need to invest a huge number of money into your business to enhance the power and the processing speed of the server. So right now you need a bigger server to support your online business so that you can make your customers happy and you can grow your business wisely. But scaling up your application using vertical scaling has some limitation, that is, you need a lot of money to scale up your application because you need to buy a huge server to support your business, and the cost of the bigger server is quite expensive. So there exists another way to satisfy your customer, and that is by scaling your business using horizontal scaling. So as we have discussed in our previous video, in case of horizontal scaling, instead of increasing the processor speed or the server size of a particular machine, we distribute the entire traffic into different number of servers so that all the traffic get distributed equally among themselves. And thus it is recommended to scale up your business using horizontal scaling rather than vertical scaling. So now you have spent a lot of money in buying few numbers of server for your online business. So now the question is, how will you distribute your entire traffic equally into all your servers? And thus here comes the use of a load balancer. So a load balancer is actually a device that distributes your entire traffic equally between all your servers, so that all the traffic, all the requests that are coming from your customers will get served efficiently, so that none of your customers are unhappy. So this is the core concept, that why and where we need a load balancer into our system. So hopefully you guys have got some basic concept about what is a load balancer and why we use a load balancer into our system. Now let's go deeply into the concept of load balancing, so that you can easily understand this concept and you can easily implement your load balancer into your design during your system design interview. So I would request you to stay till the end of this video, so that you can get each and every concept of load balancer, which will help you to understand the concept in detail. So stay tuned with me till the end of this video. So since now we have got the overall concept of load balancing, now let's go into the detail of what is a load balancer. So a load balancer or a load balancing is a critical concept of a distributed system, because a load balancer simply distributes the incoming request effectively among the cluster of servers to improve the responsiveness and the availability of the application. One more thing we have to understand about load balancing is, like, for example, in case of horizontal scaling, we have 6 servers that are running our processes, and in case if one of the servers stops working due to malfunction or technical failure, then the load balancer will stop sending the traffic to that defective server. And this is how a load balancer helps to keep the application available for the customer for most of the time. Now since we have understand that what is a load balancer, now let's understand that what is actually a load balancer, whether it is a software or it is a hardware. And to understand that concept, we need to understand the type of load balancer that are available for our distributed system. So a load balancer can be of 3 types. Number 1, load balancer as a software which exists on the client application. Number 2, load balancer as software which exists on the service end, that is the backend of the application. And number 3, there can be a hardware load balancer also that supports the distributed system. So a software load balancer that resides on the client application is probably the cheapest way to implement a load balancing. In this case, all the logic of your load balancing resides on the client application, and on starting of the application, the client application is provided with a list of web server or the application server with which it can communicate, and the client application pick up the first one from that list and send the request to the server. And in case if there is a failure from the server side, then the client application sends the same request to the next server. So this is the most easiest way to implement a load balancing. Now the second category of load balancing is the load balancer on the service end, that is on the backend side of the application, which is the most common type of load balancer available in the market. So a software load balancer is a piece of software that receives the set of requests and route them according to a set of rules or based on some algorithms, which we will see on the later part of this video. And the third type of load balancing is the hardware load balancer, which is actually a physical device used to distribute the web traffic across a cluster of web servers to handle the traffic efficiently. So if you want to know about the 3 types of load balancer in much more detail, I will give you the link in the description below, from where you can get some more information about the type of load balancer available in the market. Now since we have understand that what is a load balancer, now let's understand why we need a load balancer into our system. So as we have already discussed previously in this video, that the main purpose of a load balancer is to distribute the traffic or the incoming requests across a cluster of servers to improve the responsiveness and the availability of the application. Now the next thing that we need to know is, apart from only improving the responsiveness and the availability of the website, what are the other characteristics on which a load balancer helps. So let's study the benefit of a load balancer. So the other benefit that a load balancer provides is it increases the scalability of the website. Number 2, it helps in redundancy of the application. Number 3, it reduces the downtime and increases the performance of your website. Number 4, it efficiently manages the failure by sending the traffic intelligently on working servers. And number 5, by increasing the flexibility of the system. So until now, I hope you guys are clear with the concept of load balancing, that what is a load balancing and why we need a load balancing into our system. So until this point, if you like the video, please do like and share this video. And if you are new to this channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. And if you would like to connect with me on social media, feel free to connect with me. I will be providing all my social media handles in the description below. So let's proceed further with the most important concept of load balancing, and that is where we need to place a load balancer within our system. So a load balancer can be placed anywhere within the application where we need to distribute the traffic within our architecture. So most popularly, a load balancer can be placed in 4 places. Number 1, it can be placed in between the client and the web server. Number 2, in between web server and the application server. Number 3, in between application server and the cache server. And number 4, in between the cache server and the database server. So all this concept and terminologies might seem quite difficult for you to understand, but don't worry, as we keep on discussing all the features and important topics of system design in our video tutorial series, all the concepts and terminologies that we have used over here will be clear to you. And that is why I am suggesting you guys that if you want to know and understand all the topics of system design, feel free to subscribe to my channel and hit the bell icon so that you never miss any video tutorial on system design that I will be uploading in the upcoming days. But as of now, let's understand the basic idea of this concept through an example so that it will be easy for you to visualize the application. So over here you can see that these are our client, and whatever the requests that are coming from our client will go to our web server. And the way we can distribute our traffic into our web server is by using a load balancer in between these two, and thus we can place a load balancer in between client and the web server. Now the next place where we can place a load balancer is between our web server and the application server to distribute the traffic coming from the web server to our application server. Now the next place where we can place our load balancer is in between the application server and the database. So over here you can see that we can have multiple database linked to our distributed system. And to keep the traffic distributed among different databases, we would like to put a load balancer in between the application server and the database server. So over here you can have one more layer of caching which will hold the most currently used data in our cache so that the fetching time of the data decreases significantly, which we will discuss in detail in our next video where we will discuss about the caching policy. Now hopefully I can say that you guys have understand that what is a load balancer, why a load balancer is used in a distributed system, and where we can put a load balancer in our system. Now you need to understand one more small concept of load balancing, and that is how a load balancer actually works. So internally, how a load balancer distributes the traffic into different servers depends on some of the algorithms. So a particular load balancer can be programmed with one or two type of algorithm built within it to distribute the traffic uniformly across servers. So one of the algorithms that works on the load balancer is least connection method. In this method, the load balancer sends the traffic to the server which have the fewer number of active requests. This approach is quite useful when there is a large number of connections which are unevenly distributed among different servers. Now the next algorithm that can work on a load balancer is least response time. In this algorithm, the load balancer distributes the traffic to the server with least number of active connections and lower average response time. Now the third algorithm that can work on a load balancer is a least bandwidth method. In this algorithm, the load balancer selects a server which is currently serving the least amount of traffic measured in megabytes, which means the server which is processing the least amount of data, the load balancer will direct all the traffic. Now the fourth and the fifth is the most commonly used algorithm used in a load balancer, and that is round robin method. So in this method, the load balancer distribute the traffic uniformly one server at a time, which means, for example, 5 different servers are connected to a particular load balancer, and the load balancer first send the traffic to server number 1 and then to server number 2 and so on. And once it reaches the end server, that is server 5, it will again start sending the traffic from server number 1. So in this way, it will keep on maintaining a cyclic loop among all the list of servers. And that is why it is considered as most efficient algorithm for a load balancer, because it distributes the traffic uniformly across different servers. So one downside of this round robin method is the load balancer will not see whether that respective server is processing any data or not. If one of the server is taking more time to process a data or a request, then there will be an overhead for that system. And to solve this bottleneck, we have the second approach of the round robin method, and that is the weighted round robin method, where each server is assigned with a weight, which is an integer number which denotes the processing capability of a particular server. Now the next algorithm that a load balancer can have is IP hash. So in this algorithm, a hash of the IP number of the client is calculated and it is directed to a particular server. And the last but not the least is our consistent hashing, which is another key component for our distributed system, and thus we will discuss the consistent hashing in our next video. So in our next video tutorial series on system design, we will be discussing the caching policy and consistent hashing. So I hope you guys are clear with the entire concept of load balancing. So if you have liked this video, please do like and share this video. And please do not forget to subscribe to my channel so that you never miss an update from my side and you are always ready for your next interview. So see you on the next video tutorial series on system design, where we will be discussing about consistent hashing and caching policy. So see you on the next video. Thank you.